The final thing we'll do in this first unit is division tests. This is the opposite. So remember, we've got really good, hopefully by now, at doing multiplication in our head. These are just some tips that I've left here for you, but I'm just going to demonstrate them, which are how do you immediately test if a number is divisible by, let's say, 2, 3, 5, 6, and 9. So there are some shortcuts. 2 ka, we've done this. It has to be even. What does that mean? The last digit has to be 2, 4, 6, 8 or 0. That's it. So if I could give you a long number, it could be 2,474,000, I don't know, 234. All right. It's a long number, but as long as this last digit is one of the even table, so 0, 2, 4, 6, 8, then this number is divisible by 2. So exam mein they might ask you, is this number divisible by 2? Don't start putting it, because it'll be paper 1, you won't have your calculator. Don't start dividing the whole thing. Main isko set up karun 2, 4, 7, 4 and then I start dividing. It's a waste of time. You should know these tests. All right. So that's 2 done. What about 3? We covered this, but 3 mein it's called a digital sum. I find that term so complicated. The point is, if I gave you a number which was 426, let's say, the test is add the digits. That's why it's called digital root. Add the digits. What is that? 4 plus 2 plus 6. What do you get? You get, so 4 plus 2 is 6. You get 12. Is this, check, is this divisible by 3? If the answer is yes, then this original number is also divisible by 3. All right, so it's a very neat trick. And by the way, notice you can keep applying it, right? Because, well, what if I applied the division test to this? I can add 1 plus 2 and I get 3. So you keep simplifying it till you get to just a simple multiple of 3, and if this is divisible, then this is divisible, and then, so it's called a digital root. I think it's a really neat trick for testing 3 key divisibility. So I'm going to delete this, and just all the tips are over here. So when you're revising, this is the sum of digits, digital root divided by 3. That's what we mean. So you can refresh this. And then the next one, 5, I think super simple. Last digit has to be 0 or 5. And why is that? Remember, when we were doing the table, we literally wrote 0, 5, 0, 5, 0, 5. And then if you fill in numbers 10, 15, 20, 25, that's how you get the 5 per table. This is just using that logic in reverse. Now 6 is interesting. What do we know about 6? Well, 6 is 2 times 3. So any number that is divisible by 6 must be divisible by both 2 and 3. And now that we've learned 2 ka test and we've learned 3 ka test, we just have to apply both. So it is the same rule. Let's say I gave you 318, yeah, and we're testing it. So 2 ka test kya hai? Is the last digit even? Yes. So 2 ka test is fine. What about 3 ka test? Let's do the digit sum. 3 plus 1 plus 8, that is 4 plus 8, that's 12. If I add them together, phir se, I get 3. So yes, it is divisible by 3. It is divisible. If it is both 2 and 3, then this 318 is divisible by 6. So that's the combo test, and you can try it, right? Like you can always just divide it if you want to be very sure. 6 5s are 30, 1 carry 8, 6 3s are 18. So yes, it is divisible. Okay, but basically you have a very quick shortcut. You can almost do this in your head. 2 ka to ho gaya. 3 plus 1, 4 plus 8, 12. 12 is divisible. Done. All right, final one, 9. So the same rule as 3, except you add the digit and it has to be divisible by 9. So take any number. I'll try 8109. All right, is it divisible? Well, let's just add the digits. 8 plus 1 plus 0 plus 9. I get 9 plus 9, 18. Is that divisible? If you're not sure, phir se ek dafa add kar lo. 1 plus 8 is 9. Okay, this is divisible, so the original number is divisible. I think these are very neat shortcuts. You should know all of them. The last terms I want to teach before we get into fractions and decimals and all that fun stuff is what is a fraction and numerator denominator. So a fraction looks like this, and it's pronounced, so this would be pronounced 2 out of 3, or so 2 over 3. So in math, you'll start hearing this 2 over 3, 1 over 2, and anytime you hear this, you can write it as 2. Imagine it on top of or over a table. ये एक table है, table के नीचे 3 है, ऊपर 2 है, so 2 over 3. And the technical term is 2 is the numerator and 3 is the denominator. ये तो for sure you need to know these terms. It will be used a lot, and this is your basic math building blocks. So numerator, denominator. And what is the intuition behind it? So let me represent it like this. Let's say you had a bar, think of it as a Kit Kat bar or Twix bar. You have a bar and we've divided it into 3 parts. ठीक है? तो 3 हिस्से कर दिए. हिस्सा number 1, number 2, number 3. So 1 over 3 just says 3 में से एक हिस्सा. So there are 3 parts. The bottom is total, denominator is total parts कितने हैं, and numerator says how many you took this many. Okay, so for example, if I just took the first part of the chocolate bar, what have I taken? 1 out of 3. This is 1 hissa, 1 out of 3, right? So there's 3 total hissas, and that's all I'm saying. It's 1 out of 3. What if I take another block? So if I've now taken 2 blocks, then it is just 2 out of 3 blocks. So these are 1 and 1, 2 blocks out of total is still 3 blocks. And finally, what if I take the whole bar? I take all 3 hissas, then by definition 3 over 3 should be equal to the whole bar, i.e. 1. So 3 over 3, anytime you see a fraction that is 4 over 4 or 3 over 3, that just means it is 1 whole bar. 3 में से तीनों हिस्से, as in the whole thing.